All right, here we have example 3. And in this situation, Greg and Paul are carrying a weight supported by 2 ropes between them. We're given an angle that each of them are carrying the weight at. And we want to find the vertical component of each person's force. So starting with the diagram is always helpful. So that's what I'm going to draw. We have Greg and Paul here. Greg, I'll do in red, is making an angle 40 degrees from the horizontal. So I'll make him in the first quadrant, 40 degrees off of the horizontal. And then if Paul is on the other side, he's making 60 degrees with the horizontal. So I'll make him in quadrant 2, and again, 60 degrees here. So this is Paul is blue, whereas Greg is red. So we see right away we don't know the force that either of them are using. So let's start by setting up our equation. We have, I'll call V vector G, vector Greg, is the magnitude of Greg's force, which magnitude of vector, try to stay consistent here, magnitude of vector G, vector Greg, I'll call just X. All right, so we'll say X times cosine of the angle, which is 40 degrees. And X times sine of 40 degrees. Great, so that's Greg's setup. Now Paul's setup, I'm going to do a similar thing just to make it a little bit easier. Vector Paul, the magnitude of it, I'll make Y. You could leave it as the double brackets and call it that way, but I just want to kind of minimize my rating, simplify it a little bit more. So I'm going to call it Y times cosine of his angle. Now remember, it's like unit circle angles, so I really want the circle from the positive x-axis, and that is going to be 120 degrees. All right, so here are the two gentlemen working together to lift the box. When you add it together, you got to think about what the resultant vector should be. The resultant vector should be, now we're assuming that they're kind of not leaning left or right at all, but they're lifting and holding a 50 kilogram weight, which means their vertical components need to add together to get 50. And again, since they're not like moving left or right at all, their horizontal components will add together to get 0. And what we have here, we have 2 variables, but we also have 2 equations. So we can make 2 equations, each with the variables, and solve by setting up a system of equations. So first I'll look at what's dealing with the horizontal components. This equation is a little simpler. So, oops, not x plus, sorry. X times cosine 40. And y times cosine 120 equals 0. That's from my horizontal components. For my vertical components, those two add to get 50. Great. I have 2 equations. My variables are x and y. To solve for them, you take one of your equations. We're using substitution here. Take one of your equations and solve for one of the variables. So I'll take this equation. It's a little simpler because it's equal to 0. And I'll solve for x. So I would subtract y cosine 120 over and then divide by cosine of 40. There we go. So I just went and solved for x in my one equation. Now you take that and plug it in for x in my other equation. And it's going to get a little messy, but don't worry, we'll get there. All right, so by substituting that in for the x in my second equation, I've eliminated x from this equation I've last written here. Therefore, I can solve for y. Looks like a lot going on here, but on the left side of my equal sign is just a binomial. It's only 2 terms, and those 2 terms have y. They each have y in it, so I can factor y out. What that's going to leave me with is I got to pause here because made a little goof over here. When you are subtracting y cosine 120 over, it's negative y cosine 120. So this should be negative here. So this should be negative here. Caught it. Hopefully you saw that and were yelling at the video. There we go. Okay. Now again, I have that blue negative sign in there. What's in the parentheses there? That is really just one term. It's just a value. That is, it's just a value. So I can divide 50 by that value, and I will solve for y. Y is gonna be 38.893. Once you get that value for y, you're excited. You figured out what we've labeled again as Paul's magnitude. And you can take that value of y and plug it in really anywhere, but I think it's easiest in this red bubble I drew over here. And you'll get x, just plug in for y, and you'll get x to be 25.386. And now you have to analyze, are we done? Is that it? I found the magnitude that each of the gentlemen are lifting with, but what I really want to find is the vertical component of each. Well, guess what? The vertical component, just plug in for your x and y, and you'll get the vertical component of each. And you will end up with Greg's vertical component is 16.318 pounds, while Paul's vertical component is 33.682 pounds. And a fun connection here at the end. Notice both vertical components. If you add those up, oh, my goodness. If you add those up, you see that I used the wrong unit. It's actually kilograms. But together they need to lift 50 pounds. Therefore, their vertical components should add to get you 50 kilograms. 50 kilograms. All right. Good job, guys. Try out this one as a little practice now and check in with your partners. One heads up. We found the vertical components on that Greg and Paul problem. This one, you're finding the tension, and the tension of the two cables is equal to just the magnitude. So find the magnitude of the two cables. It's going to be a similar system of equations. All right. Great job. Best of luck. Compare your answers with your group mates.